I guess I better turn this on so you can see what we're doing. All right, there we go. All right, so just quickly, we're going to review working with rational expressions. So, a rational expression, what we're talking about is, a rational expression is where we have a polynomial divided by another polynomial. So we're just making fractions of the polynomial expressions that we've been working with for the entire chapter. So the tools that we've worked with already, finding zeros, evaluating the functions, those kinds of things, that is going to come into play when we deal with rational expressions, because we have polynomial on the top and polynomial on the bottom. But what we're doing today is just simplifying rational expressions. So I just wanted to do a couple of examples of simplifying a rational expression, so that we can hopefully remember the process. So an example of a rational expression would be something like 2x squared y divided by xy minus y. So our basic tools for simplifying rational expressions is we're going to factor, cancel, and common denominator. So we're looking for opportunities to factor, we're looking for opportunities to cancel, and when we add or subtract, we have to find common denominators. So that's going to be our main thing. When we cancel a factor, we have to be sure that we're careful about our domain restrictions. So, for example, on this one, if I in the denominator, I have a factor of y in common. So I could write this as 2x squared y. And I'm just going to factor out this common y, so I get y times x minus 1. So I just took the common factor of y out. And now I'm going to, because there's a y on the bottom, and this y is multiplying on the top, I can cancel those. So I factored, now I'm going to cancel. I'm going to say this is 2x squared divided by x minus 1. And that's all we're left with. But down here, before I canceled, if y was 0, I would be dividing by 0. Well, when I cancel the y out over here, the y goes away. I still have to be careful where I'm still saying that y does not equal 0. It doesn't show up here, but my original function has it in here, so we're saying y can't equal 0. We can't divide by 0. But the basic idea here is we factor out this y and then we cancel it. So that's one way that we work with a rational expression. Questions on that example? Yes?
I guess I was just wondering, if that y was 0, then would the y on the top also be a 0? And if 0 divided by 0, is that irrational or is it 0?
That is undefined, basically. And we'll talk about what happens when we have a rational function, when we have a factor of 0 on the top and a factor of 0 on the bottom. It makes something specific happen to the graph. Yeah. All right. So let's look at a little more complicated example. X squared plus 8x minus 20 over x squared plus 11x plus 10. We want to simplify this. So what can we do here? Factor both the top and the bottom. So how's the top going to factor? You know it's going to be x and x, and on the bottom it's going to be x and x, two parentheses. And what we usually hope with rational expressions is that we can factor and something cancels out. So we hope that that's what's happening. So what is this going to be? 10, positive 10 plus 10 minus 2. And I'm guessing now, since I have a plus 10 and a minus 2 in the top, usually the way these problems are set up, just because they come from a book and they're for you to practice, that there's probably going to be an x plus 10 or an x minus 2 in the bottom. Usually the way it works out. You can't count on it, but usually that's how it's going to work out. So how is this one going to factor? X plus 1, x plus 10. And we get the x plus 10 and x plus 10 canceling, like we thought might happen, and this is x minus 2 over x plus 1. But because we have this factor, we're canceling out this factor in our original expression. If x is negative 10, it's going to make this 0. So we're going to say x cannot equal negative 10, because that would make a 0 here in the denominator. We get a 0 in the numerator also. We're saying x can't equal negative 10. All right. Questions on that example? So another one, that's just another type of problem. 4y minus 16 divided by 5y plus 15, and we're multiplying, so we're multiplying two rational expressions, 2y plus 6 and 4 minus y. Now, the brute force method of simplifying this would be to multiply this all out and then see if we can factor. But to have a little more finesse with this, we want to see if we can factor some things out and cancel before we have to multiply. So, what could I factor out of the numerator here? What's common to both terms? A 4. So I'm going to factor out this 4. So I'm going to write this as 4 times y minus 4. What can I factor out of the denominator here? 5. So I'm going to write this as 5 times y plus 3. And I'm multiplying, what can I factor out of the numerator here? 2. Y plus 3. Oh, look at that. I have a y plus 3 and a y plus 3. So we get to cancel. And what could I factor out of this one? How about a negative 1? I'm going to factor out a negative 1, and I get a y minus 4. And everything with the y cancels. I have a y plus 3 and a y plus 3. That cancels, that cancels, that cancels, that cancels. And I get 4 times 2 is 8 over negative 5. So I get a negative 8/5. And we canceled these factors out of here. So we're saying y cannot equal negative 3 and y can't equal 4, because that would have made our original, we would have a 0 in the bottom of the original. Whoops, that should be cannot. Are we good on that one? So we could have multiplied this all out and then factored, and we would have gotten the same answer. This is a lot easier. Just a couple more examples and then we'll stop. 2x minus 1 over x plus 3 plus, now we're adding 1 minus x over x plus 3. So what can I do here? I can just add the terms on the numerator, right? Because we have a common denominator. So I have 2x, my like terms, 2x minus x is just x, and a negative 1 plus 1 is just 0. And I have x plus 3 in the denominator. So that simplifies to x over x plus 3. And yeah, we're saying x cannot equal negative 3 because that is undefined. All right, one last example. This is the most complicated one that I'm going to do here. X minus 4 divided by, and we have this nice quantity x over 4 minus 4 over x. So what do we need to do here? So we need to
the bottom cancels out.
The bottom cancels out. This is x minus 4 and this is 4. This is x over 4 and this is 4 over x. So we wish they would cancel out, but they don't. So we have to add this fraction in the denominator. So I'm going to leave this x minus 4 in the numerator. What do I have to do here to get a common denominator?
Multiply the right side by 4.
Multiply the
left side by x.
right side by 4, left side by x. So I'm going to write that in red here. So I'm going to multiply this by x and x over x, right? Times x over 4 minus, and we're multiplying this side by 4 over x. We're multiplying this side by 4 over 4 to get our common denominator. So we get x minus 4 over x squared minus 16. This is x squared, this is minus 16, and our common denominator is 4x. And now someone said it before, when I divide by a fraction, what am I doing? Multiply by the reciprocal. So this equals x minus 4 times 4x over x squared minus 16. And we can think of this as x minus 4 over 1 if we want to. So what do we, and what about this x squared minus 16? Factor. So I'm going to, before I multiply this out, I'm not going to multiply it out, I'm going to multiply it out at the very end. So I have x minus 4, I'm going to put that in parentheses, times 4x. X squared minus 16 factors to x plus 4 and x minus 4. And these x minus 4s cancel. And I get finally 4x over x plus 4. And when we cancel out this x minus 4, we're saying that x can't equal 4 because that would have made this 0. Questions on that one? So when you're working with rational expressions, when you have a quantity, something like x minus 4, before you multiply it, wait until the end because you might end up with something that ends up canceling with that. Because it's really tempting to say, okay, now I need to distribute here, but we have this in the denominator where we could factor that and cancel something out. So a lot of times when we're working with rational expressions, you end up with a lot of cancellation that can happen. Doesn't always happen, but a lot of times the problems they give you in books, they set it up so that you end up canceling a lot of factors. All right, so The rest of the time, we just have to, I'm going to pass out this